Hey there, welcome back. So today we will discuss about linked list, and as the name suggests, this list is linked with one another. Now what exactly is linked with one another? These are the specific nodes which contain data and link to the next node. So all of these nodes are independent memory chunks which contain data and link to the next node. Now how exactly this works? Let me show you via this very simple diagram. Imagine a scenario where we are creating a linked list. In those cases, we only have the address of the first node, and that initial start is the first node which contains only the address, and this looks like this. So here is the node, and we have a initial node which has only address, and then definitely there is a weird looking list in front of us. Means we have the address of the first node, then we have the address of the second node, then using the address which is stored in the second node we will reach the third node, and then finally we will also reach the fourth node. And when there is no address to the furthermore node, then that's definitely the end of linked list. So this diagram is a messy diagram, right? And in here we start with an address and we reach a first node. With first node we get the address of the second node. Likewise we get the address of the third node, fourth node. Finally we reach a node where we don't have an address to the next node, which is nothing but the linked list. If we simplify the diagram, this might look like this, where we have the first node, then we have couple of nodes with data and addresses to the next node, and finally the last node where we don't have the address. So this is all about linked list. This acts exactly like array list, but the internal working is different. So the linked list is collection of nodes, and a node contain data and the address of the next node as denoted and shown in this diagram, which is cool. Now as we can deal and modify the addresses, we can definitely perform operations in a very memory efficient manner. We can remove a node, we can destroy the information which is there in the node, and we can update the address in the previous node easily and update the address with the next node which we would like to link. So little confusing, right? Let me show you via a more expressive diagram. So for example, we remove the node number 2. Now there is broken link. So the address at node number 1 needs to be updated with the address of node number 3, right? So we will update the address, and hence the node number 1 would be now connected with the node number 3, which is cool, right? And in order to perform this operation, we would not require some additional linked list. We need not to copy some information. This is memory efficient, and this is the advantage of linked list. Rather, the operation could be slow in many scenarios because we need to traverse every node in order to get the specific part, which is an disadvantage of linked list. But definitely this is how we can deal with linked list. Now friends, if you wish to research more on linked list, then I have a course on data structures based on C programming language, but that course can help you to understand linked list. You can check my profile on Udemy, and you can also visit my website where you will find this course on data structure. Rather, this is a very old course and I might discontinue this as well because the content is really old, but definitely the course can help you with linked list. If the course is not available by any chance, then you can also research more on internet, because linked list is definitely a greater chapter which require more time to explain each and everything related to the linked list. Nevertheless, let's proceed further and check a scenario where we would like to add a new node in some specific position. So let's proceed further. For example, here is a new node which I wish to add before the last node, right? So the second last node, I wish to add this new node at that position. So what should be the ideal solution? Definitely I need to update the address content in our second last node, right? So how I will do that? I will update the address at the current second node. So I will add in the address of the new node Now the second node has started pointing the new node, and then finally the address in the new node needs to be updated to the last node and hence connecting to the last node, and we have the new linked list and successfully added a new node. So this is how we can like deal with linked list. How the internal working is done is something you need not to worry about, because collections framework will take care of linked list and the working and the operations of linked list. But always remember that linked list is memory efficient, array list is speed efficient, which is more faster than linked list. So there are things to remember. Array list is not memory efficient but fast. Linked list is memory efficient but slow. So this is it for today's video. Hope you guys understood what I was trying to convey. Thanks for watching and take care.